Hi everyone, Teacher David S. here, your math teacher at ReachOut. For this week, I thought I'd be sharing a grade 6 Singapore Math Olympiad question from one of our courses. The question reads, in the quadrilateral below, we have angle A is equal to 60 degrees, angle B is equal to angle D, which is 90 degrees, BC, the length is equal to 4, and CD is equal to 6. And then the question is, what is the length of AB? So what's this length? So what I'm going to do as step one, or actually before that, I will ask you to pause the video and you can have a go at this, or you can let your child have a go at it before I share the solution. So the first thing I'm going to do is I'm going to fill in information on the diagram which has not been provided in the question. So angle A, for example, is 60 degrees, angle B and angle D, both of these have already been filled in for me. The length of BC is equal to 4, and CD is equal to 6. Great. Okay, so my initial thoughts are, what can I do with this quadrilateral? Well, actually I can't do much, and that's because there's nothing really special about this quadrilateral like there are for parallelograms, trapezoids, squares, rectangles, rhombuses, and so on. All of those shapes have parallel sides or some kind of relationship between the angles and the side length. In this quadrilateral, things aren't very straightforward, right? Because I don't have that nice geometry. So what I'm going to do is I'm going to create some nice geometry for myself. And what I'm going to do for that is I'm going to extend the length of AD using a bit of imagination. And I'm going to do the same for length BC. And what I've done here is I've created a nicer shape. I've created a triangle for myself. I've modified the diagram slightly. But it's not just any triangle. This is a right angle triangle, right? And right angle triangles are super useful because there's so much we know about them. There's so many theorems out there. So it's going to provide me with a lot more tools to be able to figure out this side length. One theorem, which is very popular for right angle triangles, is the Pythagorean theorem. So I'm probably going to be able to use that in this question, right? So what I might do is I might remind myself of the theorem. If I have side length A, B, and C, where C is the longest length, and it's of course a right angle triangle, it is always true that A squared plus B squared is equal to my longest axis squared. Okay, so for AB, what I'm going to do is I'm going to assign it the value of x, because I don't know it, right? And in problem solving, if we don't know variables, we don't know information, we can assign variables to that. Okay, so the goal here is going to be to get this side and this side, or some more information about those sides, because in the Pythagorean theorem, you need two other sides to get the third one. Okay, so I'm part way here. I have this length, I don't have this length, and I don't have this length. If we're stuck with triangles or any shape, if we're doing any geometry problems, it's very useful if we don't know information about the sides to look at the angles. So one thing I haven't filled out in my triangle is my third angle. So if I do that, I'm going to get that this is equal to 30 degrees, right? Because if this is 60, this is 90, 60, 90, 150, the remaining angle has to be 30. Now there's another theorem I can use. And that is because this has become what's known as a special triangle. It's a 30, 60, 90 special triangle. And the theorem for this is that if you have a right angle triangle with angles 30, 60, 90, like I have in my question, it will be true that the ratio of the length will be 1, root 3, 2. They'll always be in this ratio. And the key thing to take away here is that the side opposite 30 degrees, so in my case it's the x, is always going to be half of the hypotenuse, or the hypotenuse is going to be double this value. So another thing I know now by utilizing this theorem is that the hypotenuse is going to be double x. It's going to be double that length, or just 2x. Okay, so actually I've got my hypotenuse. I'm figuring out this x. Both of them are in terms of x, very convenient. Now I really need this side. Again, I'm not sure what this length is just by looking at this quickly, So what I'm going to do is I'm going to fill in angles. So this has to be 90, right? It's a straight line split in two, must add up to 180. So my remaining side then has to be 60 degrees. So what I see is I have another 30, 60, 90 triangle within the larger 30, 60, 90 triangle. So the relationship between sides of this triangle are still going to be true, right? As I've shown in my diagram, where this is my hypotenuse, right, opposite the right angle. That's going to be double the side opposite 30 degrees. So this hypotenuse is going to be double this, so it's going to have a length of 12. Right, so now I'm going to see if I can apply the Pythagorean theorem, and I already know that I'm going to be able to solve for x, and the reason is because I'm going to have an equation when I use this Pythagorean theorem, right? This squared plus this squared is equal to this squared. I have one variable, one equation, which means I can solve for that variable. So using the Pythagorean theorem, x squared plus 16 squared, right? 4 and 12, 16, is equal to 2x squared. So that means x squared plus 256 is equal to 4x squared. And solving that, 3x squared is equal to 256. X squared is equal to 256 over 3. So therefore, x equals everything square root 256 over 3, which is the same as root, that's 265, 256 over 3. So that's the same as root 256 over root 3, which is going to be 16 over root 3. And I am done. And the units for that, of course, are centimeters. All right, I hope you enjoyed this week's problem. If you have questions about the Singapore Math Olympiad classes, please contact our course counselors, or if you have questions in general, feel free to contact them. I'll see you soon. Bye-bye.